This is one way to solve a system of three equations and three unknowns. Basically, what we're going to do is we're just going to pick a variable to eliminate, and we're going to eliminate it twice. And then we'll break this down to a normal two-equation system with two unknowns. So let me number the equations so you know what we're looking at. You can see immediately I can see that the 6y's in equation 2 and 3 can cancel just by adding. And then if I did that, I'd have to get another equation by eliminating the y from this. That's not too bad, but I don't like the 5 and the 6. I just don't think that's the best. It might be a little bit more complicated because I see over here smaller numbers with the z. And for equations 1 and 2, I can easily eliminate this 3z just by multiplying by 1 by positive. And then I can go and eliminate this 2z with one of them. And they're just smaller numbers to deal with. And it doesn't matter what you do. But sometimes the planning ahead of time is going to make your life a little bit easier. So anyhow, to get rid of the z for equations 1 and 2, I'm going to leave 1 alone. And I'm going to multiply equation 2 by a -1 because you'll see why immediately. Because now when I add these two together, the z's will cancel out. So I have a new equation, -2x plus 11y equals 24. Now be careful here. If I could have made a mistake, I don't know. There's a lot of places to make mistakes here, so just be careful. That's the best advice I can give you. So now this is a new equation. Let's call this equation number 4. I need to make an equation number 5 that has an x and a y, so I can just use our normal two equations, two unknowns. So I have to get rid of the z's again. I can't obviously use the same two equations I started with. So I'm going to go with 2 and 3. I'm going to do the same thing as I did over here. So to do that, to get rid of the z's using these two equations, easiest thing to do is multiply the number 2 by 2. I'll get -6z. And number 3 by 3, I'll get 6z. And you add them together, they will cancel out. So again, equation number 2, I'm going to multiply that by 2. And I'll get 10x minus 12y minus 6z equals -28. And then for equation number 3, I'm going to multiply that by 3. And I'll get -18x plus 18y plus 6z equals 3 times 8 is 18, 3 times 1 is 3, plus 1 is 48. So you can see there is a lot of places to make mistakes. Hopefully I did not. When I add these together, I get my fifth equation. So now you have a fourth and a fifth equation. They both only have x and y's, and now you just go with the normal two equation system with elimination. So let's do that quickly. That should be pretty easy. So if you look at 4, I have this -2x. If you look at 5, I have this -8x. The y's, I can't really get, it's not going to be easy to eliminate y's. So before I start, I think if I just multiply 4 by -4, I'll get 8x, and that will eliminate this -8x pretty easily. So again, equation number 4, I'm going to multiply by -4. So I'll get 8x minus 44y, and then -4, that would be 4 times 4 is -16. 4 times 2 is 8, plus the 1 that carried is so negative 96. Hopefully that's right. So I did that because I can now just move equation 5 right over, and you can easily see, oops, that's an x. You can easily see that the x's are going to cancel. So all I have to do is add them straight up. That's an x. That's 0. Negative 44y plus 6 is negative 38y. Negative 96 plus 20 is a negative 76. So y equals negative 76 divided by negative 38. 76 is exactly twice 38, so that's 2. So that worked out nicely. They don't always work out nicely, but most of the times when you do them in like a math text, they will, just because it makes it simpler, I guess. We're not done because we only have y equals 2. We need to plug it in to solve for x and z. So I'm going to look at the two equations I had and try to use the easiest one to solve for x. I'm going to use equation number 4. So for equation number 4, it's negative 2x plus 11y, and I said y is 2, equals 24. 2x plus 22 equals 24, and 2xm would equal 2, and divide by 2, you get x equals 1. I think I screwed up there because I know what the answer is. Thank you. It was negative 2x, so x equals negative 1. So now I have x and y solved for. I have to solve for z. And now you have to use one of the original equations. I'm going to use the first one, 3x plus 5y minus 3z equals 10. So here we go. So number 1, look at it. We have 3x. I just said, here's equation number 1. 3 times, be more organized than I am. This is horrible. But 3 times x, 3 times a negative 1, plus 5 times y. We said y is 2. Minus 3 times z. That's what we're solving for. And that equals 10. So I have negative 4. Oh, no, oops. Caught myself. Negative 3 plus 10 right here. So it's 7 minus 3z equals 10. I'm going to subtract 10. Subtract 7. So negative 3z equals 10 minus 7. And then divide by negative 3, you get z equals negative 1. So the solution is, you usually get ordered pairs when you do 3 systems. We have an ordered triplet, x, y, z. Now, those are right because I knew what the answer was going to be. But you should check those. You just throw them into any of these equations. I want to use equation number 1 because that's the one we use to get z. Just throw it into equation 2, see if you get negative 14. And to be extra safe, you can throw all those in equation 3 and get negative 16, but that is it. Not too bad. It's just tedious, but it's pretty easy. It's just as easy as solving any 2 by 2. And that's it.